Hi, this video is designed to give you a rough overview on mirrors and lenses. So we'll start off with a converging lens. And the characteristics of a converging lens is that we have a shape that's designed so that it bends the path of light based on where light hits it. So here's a ray of light that's coming in parallel to this principal axis. And when it hits the lens, it's going to bend twice, really, on the way in and on the way out, and then winds up going through the focus. It's going to be true for any ray that's parallel to the axis. They're all going to bend and go through the focus. So a converging lens has the ability to bring light together to a focus. Now, if the object is really far away, then all the light winds up going pretty much through the focus. You can see in this case we have our object A, and then the image of the object A prime. It's very small and upside down. So this is how you can use a converging lens to create a fire using the sun, is because the sun's rays are very powerful, and the lens is going to concentrate all that energy to a single point. Because really, what the lens is doing is creating an image of the sun, and the image is right at the focus. So what is an image anyway? Well, if we take a look, we can draw rays of light coming out from all directions from this object. But there are a couple of easy ones where we know exactly what the path is. So a ray parallel to the principal axis is going to refract through the focus. We already talked about that. And a ray that starts off at the object and goes through the center of the mirror is not going to be refracted. It bends a little on the way in, but it bends back on the way out. And the intersection of those two is where the image is. So our image in this case is smaller and upside down, and it's outside the focus. Let's take a look at the relationship as we move our object back and forth. As our object comes in closer, then the image moves further away and gets larger. As we move further away, the image gets smaller, but stays inverted. Now, something really interesting happens when you get inside the focus. Closer and closer. Boom. So what's that all about? Well, parallel and through the focus, and then through the center. But if you look at these two rays, they don't come together, they don't merge. But for the viewer on the other side of the lens, as they look at this light, they're going to say, hey, it looks like those two rays come from the same point that's somewhere up here. The image that we're tracing is the top of the person's head. And so the top of the person's head is right side up now and much larger. So now this is a magnifying glass. The length of the focusing element is related to something we call lens power. So power is the ability to bring light together. And if the focal length is longer, then our lens has less focusing power. So power is actually the inverse of the focal length, and it's measured in a term called diopters. And if you have corrected vision, you have a prescription for glasses or contact lenses that has units of diopters. Let's take another look at what focusing really is all about. So what it means to be in focus is that if we put a screen there, we ought to be able to see the object. But in this case, it's not sharp because the lines are not really coming together the way they should. They miss a little bit. So that results in an image that's blurry. But if I move this back to where, oops, now I went too far, so it's blurry again. So let's call this a screen. If I put the screen in the right location, then the image is sharp and it's in focus. This is called a real image because it can be projected. Let's go back and take a look at that example from our converging lens. Right, and in this case, we see that the rays that are caught by the lens are brought into a central focus. So once again, this is a real image because the light actually comes there. And if you put a screen, you'll see an image that's very clear. But here, the light doesn't actually come together on this side of the lens. It just looks like it had started at the same point on the other side. This is called a virtual image. The light doesn't really go there. It just looks like it came from there. We can actually see similar things happening with a diverging lens. So a converging lens can make a real image. It also can be used as a magnifier. But with a diverging lens, a ray parallel is going to be split apart and bend away from the focus. And again, a line through the center is not going to be refracted at all. So again, these two rays do not converge, but it looks like they had started at the same point. And so once again, this is a virtual image. Now you notice as we move our object back and forth, that the image is always virtual for a diverging lens, and you would never be able to project an image with this, which sounds odd. See, for a converging lens, any image you've ever seen that's been projected on a screen or a wall has always been a real image that's brought into focus with a converging lens. But you might think the diverging lens can't do that, so what good is it? And it turns out a diverging lens is actually one of the most common lenses that we see in use. And a diverging lens is important, especially for nearsighted people, because their eye has too much focusing power and can't relax enough to focus on things far away. So a diverging lens is a good solution for that. A diverging lens will reduce the power of a person's eye, allowing them to focus on things that are far away. And about 40% of people are nearsighted. So this is actually probably one of the most common lenses in the world. Let's take a look at mirrors really quickly and see what kind of attributes they have. So let's start off with a convex mirror. If you saw the video I did before, I was able to start a fire. And let's see which kind of mirror is appropriate for that. Well, here's a convex mirror, and very similar to what a lens is, a ray of light comes in and then bounces away, like imagine you were playing wall ball on this curved surface. That makes sense, so that it would bounce up. And it bounces up in a direction so that it looks like it comes from the focus. Now, this is a big circle here, and this is the center of the circle. So the focus is 1/2 the radius. And so this distance from the center to the outside is the radius. The focal length is 1/2 the radius. And then if we throw a ball straight at the center, it's going to bounce straight back. So these two rays are not going to intersect, but it looks like they might have somewhere far away. And so if we trace the rays back to where it looks like they came from, again, we have an observer over here who's looking at these two rays. And oh yeah, it looks like they might have come from the same point. So this would be the image. And it's smaller. And it's right side up, but it's virtual. Now, a concave mirror is the one I used to start a fire with. And what a concave mirror does is that rays of light that are parallel to the principal axis will reflect and go through the focus. And rays that go through the center bounce straight back. So the intersection of those two is where the image is, and that's a real image. So you can project that. Before everything went digital, drive-in movies used to do this. They had a really bright light called a carbon arc, and they would use that to generate enough brightness so they could paint in a huge screen with an image. Now, if we move further away, whoops, not that far away, there we go. Then you can see that the image is getting closer to the focus. And when I started to fire with a concave mirror, I essentially used the sun as a source, and I put the image right where the paper was. So this kind of mirror can definitely create a real image because the light does actually converge. And if you put a screen there, you'll see the object. Oh, there we go. So this is sort of like the drive-in movie theater, a real image that's getting larger. As you get inside the focus, you can see that now we're in virtual territory again because the light doesn't actually converge. But if you extend these two rays, if you extend these two rays back to where it looks like they came from, then we get a sense that the image is larger and it's right side up, but it is virtual, so you can't project that. Okay. So why would you ever want to use this? Well, this is a magnifying mirror. It's very similar to a magnifying glass, but this is a magnifying mirror. And they're called makeup mirrors. So that's what I was looking for in the pharmacy when I was looking for a concave mirror. I asked them for a magnifying mirror. So back to the convex mirror for one last point. Again, if a convex mirror always makes a virtual image, then what good is it? I mean, you can't cast an image. You can't really use it for focusing or anything like that. And it always makes things smaller. But here is the benefit for a convex mirror. Convex mirrors are actually, aside from flat mirrors that you have like maybe in the bathroom to brush your teeth, convex mirrors are probably the most common. They're a lot more common than concave mirrors. Concave mirrors are good for magnifying. And so, like I said, you could find them for makeup mirrors in the pharmacy. But dentists also use concave mirrors to magnify what they're looking at in your mouth. A convex mirror, though, has lots and lots of applications. And the reason why, even though it makes things look smaller, it enables you to see more stuff. So by packing more stuff in an image, it has the appearance of something being further away. So in the hospital, if you're going down the corridor, all the corners in the corridors for the hospital, or the hallways, or the stairs, all have convex mirrors, so you can see around the corner. You can see if somebody's running and they have a patient on a gurney. You'll see them in stores, so the clerk can keep an eye on those little kids in the back trying to fill their pockets full of candy. Or sometimes people put them at the end of their driveway if it's hard to see cars coming. And so that will expand their field of view. But the most common place you see convex mirrors are in cars on the passenger side. And placing a convex mirror there is great because it helps you see more stuff. It has a wider angle, but it does make things look smaller. So since they're smaller, they look further away. That means that objects in mirror are closer than they appear. Do you remember this scene from Jurassic Park? Fun stuff.